then if you want to say hi or whatever you want to say, and then I will just start with the video questions, if that's okay for you.
That's totally fine.
Great. Thank you so much. Okay. So in that case, I think... here you can tell Dave to start the stream. Okay, great. So...
And then don't look at me anymore.
Yes. Okay, so Dave, if you want, you can press the button. Hello. Welcome everyone to the European Astro Challenge 2019-2020 webinar with astronaut Luca Parmitano, who is where are you from? Where are you in, Luca?
I'm at the European Astronaut Center in Cologne.
Nice, that's really nice. Okay, so here I am at ESTEC, the European Research and Technology Center. I am alone, so I'm in a safe space, so I can take it off just for now. So I will just introduce people who are involved in this webinar today. I am Elsa Maria Sanchez. I am the program manager of the European Astro Challenge on the European Space Agency side. As you know, the challenge is run by the European Space Agency and the Raspberry Pi Foundation, who are in the UK. So our team there in the UK is also watching us, and we are doing this on behalf of them as well. And in our team today, there are helping me Alana Bartolini, who you see as well. They are joining me also. It's joining me as also Dave Hannes, who is doing the live stream so that you all can see this webinar. We are joining virtually, all of us, as you know. So today is a very special day because we are celebrating the completion of the European Astro Challenge 2019-2020. So as you know, the challenge has been postponed a little bit. We had a bit of an impact with COVID. They gave a deadline extension for all the teams to complete their reports. And now we are closing up because we chose the highly commended teams, which we want to give a great congratulations from here. And yeah, thumbs up for the amazing work. So their prize for having done an amazing job is to get to ask one question to astronaut Luca Parmitano. So what we did is to ask all of these teams to submit to us 2 questions via video, which we have then selected one of them because we have 16 questions. So that's a lot, and we have enough with that to fill up all of the time. And we will just play one after the other, and we will get some insights from the life of Luca, hopefully. So just a little bit of an overview of the European Astro Challenge. It's a challenge in which students, they get to write their own computer programs, and we send them to space. We send them to the ISS. They run there. We gather a lot of data for them, so humidity, pressure. We take some pictures of Earth, and then they get the data back. They do their report with the results. They submit it to us back, and then we judge and we choose the best ones, which is a huge and difficult task because they are really, really good, all of them. So, but then in this case, this year we selected 10 winning teams and 8 highly commended teams, of which all of those 18, 16 have submitted the questions and are the ones who will participate in this event. So, just a few words about you, Luca. You please. I hope I got nothing wrong, but you can tell me if I do. So, Luca is an Italian engineer and astronaut in the European Space in the European Astronaut Corps.
I'm not an engineer.
Oh, no. That's horrible. That's the first slide I got wrong.
That's
so
okay.
Tell me.
I'm a test pilot.
Test pilot. Okay. So, Italian test pilot and astronaut in the European Astronaut Corps, the European Space Agency. That's fine, right?
Yeah.
He participated in 2 long-duration missions, Expedition 36 and 37, and Expedition 60 and 61, the last one being the one where you were a commander.
That's correct.
And then you have been a total of, I hope this is right, 367 days in space. And you've done 4 EVAs.
I've done 6 EVAs.
6 EVAs?
Yes.
Okay. Some of the data available is not...
And I've done 366 in a few hours, over 366.
Well, that's really impressive, and I think we are all amazed about that kind of experience in space, and that's why everyone is really keen to ask you questions. Actually, you're really young still, so it's amazing for what you've done. So, so Luca just came back in February of last year, 2019, right, from your last mission.
2020.
2020, yes, yeah, exactly.
Yes. I only came back about a little over 6 months ago. Yes, I landed in the steppes of Kazakhstan on the 6th of February.
Okay.
About a little over 6 months ago.
So quite recent experience on the ISS. So okay, we will get to know some more about your life. So hopefully you get some challenges from the questions you get, and we can get some more insight about you. So okay, do you want to say also a few words if you want, and then we will start with the videos?
The only thing I want to say before we start with the videos is that I was actually in orbit when we launched the Astro challenge. I played with the little robots on orbit, the Raspberry Pi and the other one. And we actually worked a lot on that because there were some issues with connectivity, and then we repaired them. It was actually a lot of work. And I do remember one special event that made it even more fun. On the day of my birthday, from the ground, they sent a special program to one of the two astrophiles. And they told me, hey, when you get to Columbus, just go ahead and blow on AstroPi. And when I did, there was a little image of a candle that came up, and then when I blew on it, the candle disappeared and it said happy birthday. So I thought that it was really clever and kind of unique. So a nice way to celebrate a birthday in orbit with a little robot.
That's really nice. That's a really, we all saw that video, we published it, and we thought it was amazing that you were able to do that on the ISS. And it's an amazing machine, no? A tiny, tiny machine that can do a lot of things, and even a symbolic thing like that. So that's really great. So yeah, you've been our ambassador actually for the European Astro Challenge during your mission. So we were very happy for that. So that's why the teams are so glad to have you today. So let's start with the questions then. We are going to start with the first one, which is from Aguirre team 1 from Canary Islands, Spain.
Hello, I'm Nayara. We are Aguirre team 1 from Tenerife, Canary Island.
Hello, I'm Daniela.
Hello, I'm Aina.
Hello, I'm Claudia, and our questions are:
what motivated you to become an astronaut?
Well, the answer is actually extremely simple. The number one motivation for me, I would say, is curiosity. And I'm not talking about the robot on Mars, even though that would have been a great answer too. But I wanted to be an astronaut for as long as I can remember, because I'm curious. I'm curious about everything. I want to know about science. I want to know about technology. I want to know about what people think. I want to know about what people do. And being an astronaut actually turns out that it is a great job for people who are very curious, because we deal with a lot of different things. There is a lot of science, there is a lot of exploration, there is a lot of technology, but mostly a lot of people are involved from all walks of life, and you get to know and interact with a lot of different people. So my curiosity, even though it's endless, has been very well satisfied by when I became an astronaut.
Thank you so much for your answer, Luca. Yeah, that's great to have curiosity is so important. So let's go with our second question. Thank you also Team Astro Aguirre team for your question. Now we go with Astro Jaslo from Poland.
Hello, we are from Astro team from Jasło, southeastern part of Poland. My name is Mateusz.
I'm Grzegorz.
Our question is, what is your opinion on legal regulation of human exploration of space? We want to express our gratitude to the creators of Astro Mission Space Lab for the opportunity to gain experience in scientific work, which will be extremely helpful in our future education. Thanks for your answer.
How cool. What an interesting question. What is my opinion on legal regulation? Well, we don't want space to become like the Far West, where the strongest person comes in and dominates and starts shooting everybody down. We want space to be an open environment for research, for exploration. We want it to be a place where all different kinds of countries can join together for a common goal and a common vision. And as a matter of fact, our flag, the ESA flag, already reflects that. We have 22 countries participating and 2 countries joining us, like Canada, who is not even European. So I think that the legal regulation is not to create limitations, but it's the opposite. My opinion is that the legal regulation is made so that we can open the frontiers and create opportunities for more, so that it's not a jungle, it's not the Far West, but is a future where we can eliminate all kinds of differences. And so with that spirit, I think it's an important step.
Thank you, Luca, for your answer. Okay, also thank you to Astro Jaslo from Poland. Now we go with the easy peasy coding Bardala future astronauts, which is from Malta. It's the first team, I think, from Malta that ever gets recognized with a highly commended prize. So congratulations, and let's go for their question.
Hello, I am Louis Samaha from the Malta team of the AstroPi 2019 to 2020 competition. My team has managed to get to the final event to ask ESA 2 questions. Here is the first one. What does your daily work routine consist of?
It's a great question because it lets me say one very important thing, that when you're an astronaut, whether on the ground or on orbit, there is no such thing as routine. One of my favorite saying, together with Chris Cassidy, who's currently the commander on the space station, when we worked together in 2013, was that every day we would look at each other, something would come up, and we would say, there is always something. And it's true. There's always something that there's always something unexpected, something that you didn't think of. And so the routine just goes out the door. But in general, what we can say is that we wake up around 6:30, because usually by 7:30 we are ready to start the day. The day starts with a call down to the ground. Usually the commander gets that to make that radio call, or one of the if the commander is busy, one of the other crewmates. But usually it's fun for the commander to just say that, good morning, Houston Space Station, Expedition 61, ready for the daily conference. And then we start the day. During the day, we always do different things. In general, we can say that on a normal day, we do science. So we have a broad experiments on board, usually about 200 different experiments per expedition. Some ongoing, some are new, some are old. Then we do maintenance, because the space station needs to be constantly maintained because it's in a very harsh environment. We have to do 2.5 hours of exercise every day in order to stay in good shape, because space is a very harsh environment, even for the human body. So when we come back, in order to be in good shape, we have to really exercise every day, very disciplined. And then there are some special activities that are non-routine, and those are extravehicular activities when we go outside, or robotics activity, where we're either moving objects around the space station, or we capture a cargo ship and we berth it. And then the fourth activity that is usually ongoing all the time on the space station is cargo operation. because there is always something that's coming and going from the space station. That's why it's called the station. And so the astronauts have to take all the new stuff and bring it inside, and take the old stuff and put it inside the cargo so that we can get rid of it. So that's the normal day. We usually work about 12 hours with a little bit of a break for lunch, but usually most people just work constantly about 12 hours. Around 7 o'clock, we have another call down to the ground. And then the only time that we have for ourselves and to relax is the evening.
Well, that seems really intense, huh? So,
it better be. Yeah, no, there's no time to get bored in orbit.
my God. Wow, that's amazing what you have done. So, okay, thank you so much, Luca. So let's go for the next team. So it's a BH Team EL, and they are from Canada. So as you mentioned them, so we have one team from Canada. Let's see.
Hi, my name is Lauren from BH Team EL from Branksome Hall, Canada.
Hello, my name is Emily from BH Team EL from Branksome Hall, Canada. My question is there a language barrier on the ISS? And if so, how do you get around it? Thank you.
Well, these are all great questions. So we try to get rid of any language barrier before we get to the space station. So astronauts from Europe, from Japan, from Canada, and from the US, so Western countries plus Japan, usually have to take quite a long language course to be as fluent as possible in Russian, so that we can communicate with our Russian colleagues as much as possible. And on the other side, the Russian colleagues, they take extensive training in English so that they have a very good grasp of English language. So what happens is actually quite interesting. In orbit, we speak what we call Ranglish, which is a mix of English and Russian, because sometimes I don't even know the English translation for a Russian piece of equipment. So when it would be really funny for somebody to look at a conversation between astronauts and cosmonauts, because we go from one language to the other according to what we're talking about. Some Russian food to me is just in Russian. So I would be saying something like, Sasha, please pass me the kasha. I don't even eat kasha, but just saying the la sauce, whatever, because I don't even know the translation for that. And the other way around, equipment, science. So it's quite funny. And I've seen the same thing happening in Canada. I've been to Canada several times, and I notice how people go effortlessly from English to French and back, depending on what they're talking about. So it's kind of like that, only with two very different languages like English and Russian. But no, there isn't a language barrier, because we really want to communicate. That's the key. When you want to communicate, there is no barrier. Language and talking is like playing tennis. You don't have to be a professional tennis player to send the ball on the other side of the net, as long as the other person on the other side can send you the ball back. And it's the same. So if I can get across what I want to say, then the other person can catch it and kind of understand it and send it back. So if there is a will, there is a way. So I never had a problem with communication.
That's really nice to hear. So yeah, that's must be a challenge to overcome. So thank you so much, Luca, for the answer, and BHTML for their question. Now we go to Team Cloud4 from Portugal. Let's see their question.
Ciao Luca, greetings from Portugal. My name is Carlos. On behalf of the Cloud4 team members, Diogo, Afonso, and Jose, during your stays at the ISS, can you describe any experiment or phenomena that you are most surprised to observe? Thank you. Ciao.
Okay, I was muted. Well, it's really hard to pick one. There are so many things that I would like to talk about, because if you're curious and and you look around, there's always something that is surprising or different and you want to respect it, especially in an environment like the International Space Station. Some things are very simple, some things are very complex, but overall, is there one thing that I can say? So one phenomenon that I remember the very first time, and I kept trying on the second flight, is the rotation. Rotations in orbit, because they happen in a 3D environment free of the gravitational effect, they have this thing where if you flip an item on the axis where it's not symmetrical, it does this very complex dance around its axis, and it's really fascinating to watch. And the more complex the structure, if it has different axes, the more fascinating it is to watch. I don't even know how to describe it, but it's a very simple thing, but almost hypnotic. The behavior of flames, we don't burn stuff very easy on the space station, but when we do, in a very contained environment, it's fascinating to watch because the behavior of the flame is different than on the ground, because the flames are round, they don't have the shape of the flame, so it's a very unique thing to observe. And then of course you look outside and you can see all kinds of things. You see the mesospheric clouds that are really, really high above in the atmosphere, but almost 85, 95 kilometers of height. And they're this amazing, amazing light blue color, almost like your shirts, but really, really bright. And they're beautiful. The auroras, australis and borealis, they're beautiful and curious. And then once I even witnessed an intercontinental ballistic missile being launched and exploding, and the plume that it created in orbit was amazing to watch. Scary, but again, curious at the same time. So there's so much. I can keep going the whole day about all the curious things that we observe in space. So, the simplest thing, somebody like you, Elsa, your hair would be floating up, and we never get bored of that. It's just, well, I don't have any hair, but we never get bored to observe such things. So, I know it really is amazing. There's so much that is different and curious when we are in orbit.
Wow, that's amazing. How many experiments have you done? This is just because the answer was really interesting. So
like I said, it's really hard to count because in a 6 months expedition, we perform anywhere from 180 to 250 experiments of all kinds. So some we don't perform, we just observe. Others we are the experiments. So it's really important. Several hundreds.
Wow, that's amazing. I think all the participants will be surprised that there are so many. So, wow. Okay. Sorry, that was my question. I got one question too. So, let's go on with the list. Thank you so much to Team Cloud from Portugal. Now we go with Team Cloud Wizards from Poland.
Hi, we are Cloud Wizard from Gdańsk in Poland. My name is Dorota Kremer.
And my name is Emily Wymysłowska.
We would like to ask you the following question.
What is your best and worst memory from outer space that reminds you of feeling extremely happy, relieved, or afraid?
Bye-bye.
Bye-bye.
Well, first of all, let me say one thing that is completely outside of the question, and is I am so happy to see so many young women, young girls interested in space and in this science. As I am the father of two wonderful daughters, I'm extremely proud to be a father of daughters, and they are the best. And so to see so many girls interested is just, it's the best feeling. It fills my heart with joy and pride. And however, answering the question, I have to say that I learned in my life, I'm 44 years old, so I'm getting pretty old now. I learned that it's better never to put stuff in ranking, because what is the point? All the experiences are different. And sometimes your best memories turn to be also your worst memories and vice versa, because something that's very scary for a moment, then a couple of years later becomes fun. And so you see things in different perspectives. So I really don't like to put things in perspective, also because it would be unjust. They're asking me about the best memory or worst memory from being outside, but I could easily say, oh, in 2013, during my second EVA, I had this emergency that everybody talked about, where my helmet in my spacesuit while I was outside started filling with water because of an emergency. But while it was happening, it wasn't certainly my worst experience, because I was just thinking about what I had to do in order to save myself. I wasn't scared, and I'm here talking about it, so it's not the worst memory because I'm talking about it. Or at the same time, I could say that in my very last EVA, at one point we were trying to upgrade this very, very, very expensive piece of equipment called the AMS-02. It's the most expensive experiment of astrophysics on board the space station. And Drew, my crewmate, and I had this huge responsibility that if we were going to do something wrong, it wasn't going to work anymore. And so we really felt the responsibility to fix it correctly. On the very last EVA, it took 4 EVAs to do the job. On the last EVA, one of the connection that I had made, very complicated procedure, hydraulic connection, I had to cut tubes and then join the tubes in a spacesuit, something that wasn't ever supposed to happen. One of the connection didn't work. It was leaking. It's the worst nightmare for an astronaut. Forget about dying. We don't care about dying. We care about failing our mission. It's a lot worse. And so when I saw that my connection didn't work, I was like, I was in shock. But then it did work. We had some extra work to do, and when we made it work, and now the experiment is functioning perfectly. So at the same time, that is a bad memory and a great memory. So there's so much to think about that it's just. I would rather tell you all the memories and all my stories and let you decide which are the best and which are the worst.
Thank you, Luca. That makes us think it's relative, no, in this way. So yeah, thank you. Okay, so let's go with Team Astro Lorenzini now from Italy. So your home country.
Hi, I'm Luca from Astro Lorenzini team. And here's my first question. Is the loneliness a problem while working for math on the space station? Bye.
So did I get the question right? What are the most critical moments? Is it loneliness? Loneliness a problem?
Is loneliness a problem? Yeah, exactly.
Yeah. Sorry, the audio was really.
It was lagging a bit. Yeah, sorry about that. Is loneliness a problem? We're working for long months in the space station, I think.
Okay, so these are tough questions, but the answer actually is quite easy. I cannot recall one moment in my life where I was lonely. Because there is a very big difference between being alone and being lonely. I've been alone many, many times. I've been alone traveling. I've been alone living and studying in Russia or moving here back to Germany right now. I'm completely alone. But I've never been lonely because nowadays, first of all, with all the technology that we have surrounding us, it's really hard not to be connected to somebody. But even when you're on a desert island, all you need is one book, and you have all the company you need. And on the space station, I didn't really need many books because I was always in the company of my crewmates. And sometimes it was actually nice to be alone. We also need our own private space. that's why we have the so-called crew quarters, so that we can find our privacy and our moments of solitude, which is very different from loneliness. I think loneliness is an inner condition. It's you can be in Tokyo, in the middle of Harajuku, surrounded by 30 million people, and be completely lonely because you're isolated, because you don't understand, or because you have so much happening within yourself that you feel lonely and misunderstood. Or you can be in the desert meditating and be perfectly happy without any feeling of loneliness. So I'm very lucky in that sense. I have never felt lonely in my life. And certainly in space, I don't recall a moment in a mission where loneliness was a problem. And I think that's true for all my crewmates as well.
That's a really nice answer, Luca. Thank you very much. Okay. Also, thank you for all the teams that have asked the questions so far. Now we go for Refresting Entrepreneurs, team from Gran Canaria, Spain.
We are Reforesting Entrepreneurs.
I'm Paula Catalan.
I'm Alfonso Medina.
And I'm Alfonso Santana. We are 3 students from Canterbury School, Spain.
We would like to ask you a question. What are the most critical moments in a mission?
Thank you very much, Luca Parmitano. We've had tons of fun participating in this challenge.
What a good question. Again, there are many critical phases. So in general, big picture, I would say that we have to pay attention to every time we are performing something that is out of the ordinary. That's true on the ground as well. But on orbit, everything is out of the ordinary. So it's really hard to put stuff in ranking. So I would say that the critical operations, just on a level of equality, would be launch and re-entry, because they are very, very dynamic operations where you have huge masses moving through the atmosphere, coming back. Everything has to work perfectly for safety. So definitely launch and re-entry. Around that, we also have the docking phase and the undocking phase, because now we have to make sure that a very delicate choreography of objects moving at 28,000 kilometers an hour at the same time are physically locking or unlocking each other. So we run risks of contact or unwanted problems. We have to fire engines, we have to move around. So anytime we have a spacecraft in close proximity of the space station is very critical. And then, of course, in terms of human experience, extravehicular activities, spacewalks are extremely complex. They require a lot of preparation, and they are certainly very critical, complex operations. And all the robotics operations as well are very, very complex. That's in general. However, it could, at the same time, if you have any kind of emergency on the space station at any time, it could be the easiest of days with an experiment that you have done 1,000 times, and then something goes wrong and you go from 0 to high criticality in an instant. So any kind of emergency becomes a critical operation. Responding correctly to an emergency is critical, and that's why we train so much for those kind of events.
Thank you, Luca, and thank you, Team Refresting Entrepreneurs. Now we go with Team Space Clutchers from Greece.
Hi there, we are the Space Clutchers
from the Technology Club of Thrace in Greece.
We are delighted to be one of the highly commended teams in the Mission Space Lab 2019 to 2020 by the Raspberry Pi Foundation and the European Space Agency.
We would like to thank in advance the astronaut Luca Parmitano for devoting his time to answer our questions.
Here are the 2 questions we would like to ask.
During the corona,
During the coronavirus pandemic, what is the most important lesson you have learned?
we have learned that we have to stay safe. Coronavirus pandemic, many countries establish a quarantine. Observing the situation from Earth, the positive impacts on the atmosphere of certain countries were visible. Was this difference also visible from space?
So, I have to say that I wouldn't be able to answer that question because, I wouldn't be able to answer the question directly because I came back when the pandemic started. As a matter of fact, the first lockdown in Italy happened about 1 week after I went to the United States to rejoin my family there. So I didn't experience it directly from orbit. However, I can say that our very complex system of Earth viewing satellites did observe changes in the levels of smog in big cities and the cleanliness of water and air in general. And I believe that my colleagues up in orbit, they were able to see it too. Very simply, some cities always seem a little bit, they're hard to take pictures of because there's always smog on top of them. It's like a cloud. And I believe that the lockdown and shutting down of many heavy industries cleaned up the atmosphere to such a point that it was easier to take pictures of them. So I believe so, even though, again, I didn't experience it myself.
I'm sure we'll then, when the time comes, we will be able to ask the astronauts that are right now in the space station, right? To see what their experience is. So thank you, Luca. So we go now with Team Wombats from Spain.
Hi, we're the Space Wombats from Instituto de Alta in Spain, and I'm Marina. I'm Judith.
I'm Hector, and also the other team members, Ana and Oscar, who couldn't be here.
And what's the biggest misconception about being an astronaut and our job? Thank you for letting us participate in the Astro Pi Challenge.
There are several misconceptions. I think that's the first time I've been asked a question, as a matter of fact. One misconception is that a lot of people expect astronauts to always be in space. So, as soon as I landed, this is the day after, somebody approached me and said, "So when are you going back up?" and I have to laugh because even during the time of the space shuttle, where there were a lot more flights and more astronauts were flying at the same time, it would still take years in between before the same astronaut would fly. At least a couple of years because of all the training required. So that is probably one of the biggest misconceptions because it's hard to understand that we spend about maybe 5% of our career on orbit, if we are lucky. And then the rest of the time, we're doing work on the ground, helping other astronauts, doing meetings, helping creating the future of spaceflight. Like a pilot, pilots are not always in the air. They're doing stuff on the ground, and it's part of their job. So that's one misconception. For me, for example, I've been an astronaut for 10 years. I was selected at the end of 2009, and I spent 1 year in space. And that's already 10% of my career as an astronaut, but that's a lot. That really is a lot, and it won't be happening anytime soon. And I'm aware of that. So misconception number one. Another misconception is that astronauts go to the moon. I keep hearing it from other people. Wow, you've been to the moon. It must have been amazing. Well, I haven't been to the moon yet, but I spent a lot of time in orbit. So. We are trying to go back to the moon. For all those watching us right now, we haven't been to the moon since 1972. I really want to go back, but I haven't had the chance yet.
You would sign up for it, right? Nice, thank you, Luca. So, okay, let's go for the next question, which is from Team Liberté from the UK.
We are Team Liberty from Camas College from the United Kingdom.
I'm Matthew.
I'm Leon.
I'm Hayden.
I'm Seb.
And I'm Henry.
Recently, you took part in a spacewalk to conduct repairs on the AMS. How do you cope with repairs like this with few resources and in general on the ISS?
These guys paid attention. I would have to contradict them. It requires a huge amount of resources to do it. And when an experiment is important, like AMS, then there are no resources spared in order to achieve the result. You have to understand that AMS is revolutionizing the way we understand the universe, its life, evolution, and composition. Until now, there were many, many theories of how the universe came to be, where it's going, what's happening. And there are still many theories, but through AMS, we were able to completely eliminate some of the theories. We destroyed them. Such theories now we know that are not possible. And I was told this by Professor Samuel Ting, who is a Nobel Prize for Physics, and he is the chief point of contact, the principal investigator of AMS. He helped design it. And when you're a physicist, a theoretical physicist, and you find a way to completely disprove a theory, it's a great revolution because now you can go on. You know that one is wrong and you have to find out another one. So AMS is an incredibly valuable piece of equipment. So valuable that even though it was supposed to last only 5 years, they decided to improve it so that it could fly on the space station much longer. So when they took that decision, they invested a lot of time, money, and resources to train Drew and me to conduct the repairs. We had specially designed tools. We had to learn how to use them. A lot of time set aside while I was on orbit to perform the EVAs, and that's the only reason why it was so successful. Because not because Drew and I are exceptional, but because the team that put it together did such an amazing job and gave us all the resources that we needed in order for us to achieve the results.
Thank you so much, Luca. So now we go forward. So we have now Team Unknown from Portugal.
Hi, my name is Lucas, and I'm part of the Unknown team that is one of the winners of the Astro Challenge.
Hey, my name is Luis.
Hey, my name is Diogo.
Hi, my name is Sergio and I'm one of the members of the Team Unknown.
The question I want to ask is, how do you feel when looking down on Earth from space and seeing how far we have come as a species?
When we talk about feelings, it's always hard to reply because our brains don't work in a linear way. You know, when we talk about sensation, it's never just one thing. It's always many, many things coming to our mind at the same time. So looking down at the Earth and thinking about humanity gave me many different feelings. So I felt very connected to humanity. I felt privileged to be far away and still being able to enjoy the view and the company of humanity through technology. And then I felt specifically for the question that the team asked me, there is an ambivalence. There is an ambivalence when you look at the Earth. I had the opportunity to observe incredibly powerful and horrifying disasters, hurricanes, forest fires, the Amazon forest burning because of men putting fire to the trees to clear up the land so that it can be farmed in the Amazon forest or in the African forest around the equator. I saw flooding of catastrophic power and hurricanes because of the impending climate change and the global warming caused by human activities. I saw the bushfires of Australia. It seems far away, but it's only a few months ago. the whole continent of Australia was covered in ashes and dust. So all these things make me stop and wonder if we deserve the planet that we have as stewards, because it doesn't belong to us, but it's our responsibility to manage it, not for ourselves, but for all life, for all living animals and the future generation. So in one way, it gives me a sense of responsibility that we need to do better. And I hope that this message arrives to the generation that now is in charge and the future generation to do a better job than my generation did and the previous one. The other feelings, however, and I would like to finish on a hopeful note, is that when I look at night at the Earth, the feeling of connection between the different countries that now we have, knowing that Europe 150 years ago was a place of constant war and skirmishes and about moving one political line left or right, north or south, creating divisions that are completely unnatural. That is a thing of the past. The European Union is an example of willing to overcome divisions and trying to create something bigger, something better, and go beyond the limitations of creating a line on a piece of paper. So that gives me hope at the same time. Seeing Europe from above as a unique country, like a brain with all the connections, almost like neurons flaring up with ideas, that gave me hope. And I think that Europe, the European Union, is a fantastic step forward in society. And so maybe there is hope.
Thank you, Luca. Okay, we have only 4 questions left. So next is Team Bloomers from Romania.
Hello.
Hello. Greetings from Bucharest. We are Team Bloomers.
Thank you for presenting us with this once-in-a-lifetime opportunity.
Which experiment had a different outcome from your expectations?
Thank you. We really appreciated this insight into the life of an astronaut.
So I would say that there are many experiments that have different outcomes. Here's the thing. I think in science, it's more important to find questions that you didn't think of, rather than finding the answers to the questions that you already have. Because having the answer, it's a stop sign. Basically, you arrive and there's a wall and there's nowhere else to go. So in general, when you have a theory and you think you know what's going to happen, and then something completely different happens, and now you have to wonder, why did it happen? What happened there? I think it's always a positive thing, because it creates more questions. It creates more curiosity, which I already said is more important. I'm not specifically trained as a scientist, so it's hard for me to explain which of the experiments came out differently than what we expected. I can tell you one thing, that we thought that repairing the AMS was not going to be possible. That was 6 years ago when we first talked about repairing the AMS in orbit. Most people said, we're probably going to break it and we're not going to be able to repair it, but at least we will try. So already that was a different outcome than expected, because it actually worked out perfectly. There is other experiments that in general turn out different than expected are the ones with fluid physics, because there are a lot of unknowns. We don't really understand the behavior of fluids and an interaction of different parts of the atmosphere with fluids in microgravity, because it's such a different environment. And then the last thing that I have to say is that in general, we don't get the results, the final results of the experiments until many months later, because we accumulate a huge amount of data while we are on orbit. And then this data needs to be analyzed for a long time in order not to make mistakes. And that is true of every kind of science. So it is absolutely true that that a lot of times we don't get the results we expect, but it takes time for us to understand it. Here's one experiment that I know that gave us different results. We were trying to grow moss. This is a Japanese experiment. We were trying to grow moss in space to see what would happen when you put it in a normal environment of 1G, in a microgravity environment, so 0G, just free-floating cells, and in a hypergravity environment, so in a centrifuge that was basically squashing the moss at a different level of acceleration. We thought that the best conditions would be either the 1G environment, which is the natural environment, or maybe the micro-G environment, because now you don't have this acceleration pressing you down into the ground. But it turned out that we were wrong. And the best results were in one of the hypergravity environments with a lot more Gs than the Earth, which makes us think maybe very heavy planets somewhere out there in the universe with a very high gravity environment might have forests of moss growing around it. Who knows? The universe really is a strange place. So that was one experiment where I know that what we thought did not happen. And actually, now we have to figure out why.
That's a really interesting one. Wow, thank you. Okay. Now we go from with Team Gesto from Italy again.
Hi guys, I'm Sofia from Gesto team. Question number 1. When you're in ISS, does your voice more or less sound the same as on Earth? Luca, help us, cause our teacher didn't know.
Well, it goes to prove that teachers don't know everything. So the sound of the voice depends on the composition of the atmosphere. And the atmosphere on the ISS inside is exactly the same as on Earth. More or less. I mean, not 100%. We have a little more CO2 because it's hard to scrub it out. That's carbon dioxide is the product of our biology. But in general, it's very similar. So unfortunately for me, my voice didn't change because any change would be welcome. I don't like the sound of my voice, and I wish I could sound more like Barry White, but no luck on that sense. However, there is one instance where our voices change, and it's when we go EVA, because in that case, we are in a completely different environment, and our instead of being at 14 psi, we're about 4 psi, which is the same atmosphere of that you would have about 3 kilometers high on a mountain, 10,000 feet or so. And our voice becomes a little deeper. Still no Barry White. I still wouldn't suggest singing, especially if you're like me inside the spacesuit. But those are the answers. So inside the space station, no, it doesn't change. If you're inside a spacesuit, it changes a little.
Okay, thank you. Nice. Okay, next we go with Creative Coders from the UK.
Hello. Hi, we're Otto and Fun from Creative Coders, and these are our questions. Question 1 is, in what way will going to space change you for life? Thank you very much. Bye. Bye.
Well, that wasn't that very cute.
It was, yes.
That was so cute. Yeah. Wow. it's always the apparently simple questions that are the most loaded, because how does going to space change your life? Well, this is the only thing I can say about it. All experiences are supposed to change us, because any experiences are the only way we can evolve. As a matter of fact, I always say that it's crazy to measure life in years, because you may live 110 years and not have and you have no experiences, or you can die when you're 30 and have had so many experiences that it was much fuller than a much longer life. So I think that measuring life in experiences is a lot more valuable as an exercise. And we should use the experiences that we get in order to evolve. So I can only hope that big experiences change me for the better more than small experiences can. But in the end, every experience is an opportunity to evolve so that I can be a little better tomorrow than I am today, and hoping that today I'm a little better than I was yesterday. So having experienced 1 year in orbit, I have seen the fragility of the Earth. I've seen the hope, and also sometimes the desperation that the beauty of our planet that we are slowly destroying can bring. It changes your view, because certainly you stop looking at nationalities, you stop looking at divisions, and you start thinking that we are really all the same, and that we're really all trying to navigate the same ocean. We are on different boats, but we are in the same ocean, which is this huge universe, and we are in this tiny spacecraft, and we need to do better as humanity to navigate, to go through all the difficulties together. It's a perspective that's being called the overview effect. It comes from watching a planet from many kilometers above the atmosphere. And I've heard every astronaut feeling that same sense of precarious beauty and fragility of our planet. And I think that's a good change to achieve that kind of awareness. So I hope that it stays with me for all these years until I fly again.
That's a really nice answer, Luca. Thank you so much.
You.
We go with the last question now. So we were a bit shocked by this team's video. It's really, you will see. Let's just watch it. It's Pardubice Pie from the Czech Republic.
Hi, my name is Filippi.
Hello, I'm Václav Pavlíček.
Hi, I'm Patrick Kartofil, and we are Pardubice Pie.
We would like to know what was going through your mind when you almost drowned in your spacesuit during second EVA, and how did you manage to keep calm and return to the ISS?
Fantastic. The creativity of these kids is superior. It's really incredible. Well, there were two things going through my mind, at least two things going through my mind when I had the emergency. The first one was a sense of ridicule, because I thought, if I die in space by drowning, I couldn't stand the idea of a newspaper saying astronaut drowns in space. You can get lost in space, you can get killed by aliens, you can disappear, you can burn in the atmosphere. Anything would have been better than drowning in space while on a spacewalk. I think that sense of ridicule really helped me because I really didn't want to die by drowning. Again, any other way would have been okay, but not drowning on a spacewalk. Of course, I'm joking. Although I did think about that, but the thing that goes through our brain on anybody, any operative, doing a very complex operation is, what do we need to do? Because we have been trained. We are trained to react to all conditions, including emergencies. So it's important to be very, very well trained, because that way you take away a part of the situation which you cannot control. I didn't know what was happening. I didn't know why I was getting the water. I had no control over that. So I put that aside and I focused on what I had with me, which was the training. I knew the configuration of the space station. I knew that I had to go back. I knew that I was by myself. I knew that I had to keep talking, and I focused my mind on the steps that I needed to take in order to save myself. But that's not my merit. It's not because I'm special. It's because we are trained as pilots, as astronauts. We are trained to solve problems and to concentrate on the solution rather than on the problem. So I was constantly trying to update my options and to figure out a solution to what was happening. Sorry, I just kicked my microphones. So yeah, that's how I stayed calm. I stayed calm because I was trained and I trusted the training that I received on the ground. So I always say that the only antidote to fear is knowledge. And for us, astronauts, knowledge is training.
Thank you so much, Luca. So, okay, we have finished our questions. So thank you very much, Luca, for having joined this event. I think it has been fascinating, at least for me, and I hope for everyone else as well. And I'm sure the students are super glad to have got such amazing answers from you. Is there anything you would like to say before I just say goodbye and we close the event?
Just one word, few words. I want to thank all the teams that participated. First of all, for participating. Secondly, for showing their interest in science, technology, and exploration. It gives me hope to see so many brilliant young minds busy in exploiting the capabilities of and opportunities that are available to them. So thank you very much. Thank you for interesting questions. Thank you for listening to my answers. It's a gift of their time, and stay curious and study hard.
Thank you so much, Luca. Thank you so much to everyone who has attended this event, to the winners and the highly commended teams. And we hope to see you very soon. We are launching the next edition of the European AstroPy Challenge on the 14th of September. This is the goodbye from this school year, and we come back in a few days. Bye-bye, everyone. Thank you so much. Bye. Bye, Luca. Thank you.